Welcome to the data metaphor space. Today, our topic is how to use a hash table to store a large amount of fruit prices and query them very quickly. First of all, I would like to invite today's two guests, Mr. Wisdom Big Eyes and Miss Alice, who likes to walk catwalks. Let the two guests say hello to the audience.
Today, we will introduce a kind of table, which is called a hash table. Believe it or not, a hash table is one of the most useful basic data structures. Moreover, hash tables are versatile. Suppose you work in a fruit shop. When a customer comes to buy something, you have to look up the price in a fruit price list, which may take several minutes, especially in a large fruit shop. If the content of the fruit price list is not in alphabetical order, you may go through each row to find the price of apples, which takes a long time. If you use the simple search method, you need to browse each line. Remember how long it takes? The symbol is expressed as O(n). If the content of the fruit price list is arranged in alphabetical order, a binary search can be used to find the price of apples, which requires a shorter time, which is O(lon). You may be thinking, is there a data structure with faster query speed? It is the hash function. The hash function is such a function that no matter what data you give it, it will return you a number.
The hash function maps the input to a number. Today, let's use a hash table to store the price of the fruit. To do this, first create an empty array. You will store the price of the fruit in this array. Let's add the price of apples to this array. To do this, give apple as input to the hash function. The output of the hash function is 3. So we store the price of apples at index 3 of the array. Next, store the price of milk in an array. For this reason, milk is used as the input of the hash function. The output of the hash function is 0. So we store the price of milk at index 0. Keep repeating this process, and eventually the entire array will fill up with prices. Now suppose you need to know the price of pears. You don't need to look in the array. Just pass the pear as input to the hash function. It will tell you that the price of pears is stored at index 4. Sure enough, you found it there. The hash function accurately points out where the price is stored, so you don't need to look it up at all. I have a question. Why is it possible to do this?
The specific reasons are as follows. The hash function always maps the same input to the same index. Every time you enter pears, you get the same number. Therefore, you can use it first to determine where to store the price of pears, and later use it to determine where to store the price of pears. The hash function maps different inputs to different indexes. Pear is mapped to index 4, and milk is mapped to index 0. Each fruit is mapped to a different position in the array, allowing you to store its price here. The hash function knows how big the array is and only returns a valid index. If the array contains 5 elements, the hash function will not return an invalid index of 100. The combination of hash functions and arrays creates a data structure called a hash table. A hash table is a data structure that contains additional logic. Arrays and linked lists are directly mapped to memory, but the hash table is more complex. It uses a hash function to determine the storage location of the element. Among the complex data structures you will learn, hash tables are probably the most useful, also known as hash maps, dictionaries, and associative arrays. The hash table is fast. In the array, you can get the elements in the array immediately, and the hash table also uses the array to store data, so the speed of obtaining the elements is as fast as the array.
Thank you two guests for the discussion and sharing today. Let's see you next time.